Please write on the heading, guys. Magnetic field. Magnetic induction. I told you now, magnetic field intensity also has another name, which is called as magnetic induction due to a circular loop at its at a point on its axis. So basically, we are going to define magnetic induction due to a circular coil at a point on its axis. Okay. So now see, guys. Suppose you have a current carrying circular coil. Okay. And this part is dashed. I won't draw it like this. I will draw it like this. Yes. Can anyone tell me what does the dashed part mean and what does the solid part mean? Yes. Can anyone tell me what is the dashed part mean and the solid part mean? The dashed part is basically coming out of plane. This is a 3D figure, है ना? And the dashed part is basically into the plane. Guys, are you able to understand the figure?
Yes, sir.
So basically, the current in this thing is going like from here to here. Can anyone tell me if you see it from right, what will be the direction of current? If you see it from here, if you see from the right of the loop, then can anyone tell me what will be the direction of current? Clockwise or anti-clockwise?
Clockwise.
Clockwise. Perfect. Yeah. So the direction of current here is direction of. That's why this solid part and dash part is just to give that clarity. Just a part of diagram. So direction of current in the loop is clockwise as seen from right. This derivation is a part of a school syllabus, so we'll write. Let us consider over here. We'll write the statement over here. Let us consider a circular loop of a radius. The diagram is not complete yet, and we'll need to draw the diagram. So I'll draw the diagram. That's why I've left this space like this only. The diagram has to be completed. So let us consider a current carrying circular loop of a radius capital R, and current I. Okay. Hello guys. Is this clear?
Yes, sir.
What
Yes,
do we
sir.
need to find? We need to find the magnetic field due to this wire at a point P, which is x distance away from center on the axis of the loop. So basically, I choose a three-dimensional coordinate like this. One axis, another axis, and can you see this, guys? This is the center, and I have chosen a coordinate axis like this, x, y, z. Can anyone see this particular thing? Can you understand what exactly how the loop plays, right? So basically, on this axis, at a distance x, there is a point. So from here to here, the distance is x. Okay, is this clear, guys? This distance is r from here to here, and this distance from O to P is x. Is this clear?
Yes, sir.
Okay. So let me just draw it a little bit more farther away. Let me draw point P over. Now, how do this thing? How do you do this thing, guys? First and foremost thing, what will you? You'll choose two small elements, right?
Yes, sir.
So let us consider two small elements. Let us consider two small elements at points. Let's name them A and B on the symmetrically opposite side ends of the diameter AB on the wire. So basically, I'm choosing these 2 points. Just write it here, then I'll tell you which points am I talking about. Okay. This is the important part of the school derivation. Please, Hannah, you need to write exactly like this. First statement, let us what is the situation, then basically what you need to find and what are you exactly doing to find out that. Are you getting my point, guys? After this, the maths part is there. So this statement only, it consider, it is like 1 mark in any derivation. If it's 5 mark derivation, then 1 mark they will give first statement. Are you getting my point, guys?
Yes, sir.
Done.
Yes, sir.
So let us come back to the diagram. So I'm basically choosing these 2 points. This is your A and this is your B. Can anyone tell me what is the direction of current at point A and B? Can you see the current is going like this? If you see from the clockwise, if you see from right at point A, the current's direction will be like this,
Inward. Yeah.
or basically like this, or can I say at point B it will be like this? Yes or no? This will be the direction of small current. Oh, sorry, the current at A and B. I can draw it like this since I have drawn a 3D figure like this, so I can draw it like this, right? Or can I write like this? At point A, the direction of current is into the plane, and at point B, the direction of current is out of the plane. Can I say it like this? If I look it from the front, if I can't see this particular thing, if I look it from the front, will it look like this? Yes or no? Yes or no? Will the front view will be like this? This is the
Yes,
3D
Yeah.
sir.
view.
Yes, sir.
The 3D view is like this. The front view will look like this. The current is going inside, and at point B, the current will be coming outside. Yes.
Yes, sir.
So if I have this particular point, please remember this is, you know, the diagram has been a little bit unsymmetric here, 4 lines here, 3 lines, but you understood that this is a circle and this is the ends of the diameter. Okay.
Yes, sir.
So I want what is the magnetic field at point B. Now, can you see if I can join this particular thing? Can you see that you can apply Biot-Savart's law individually on points A and B? So if I apply Biot-Savart's law individually on point A and B, this is R, this is X, this is also R. So will this be under root of R square plus X square? And will this also be under root of R square plus X square? Yes or no, guys?
Yes, sir.
So now can you see over here the position vector from point A to point P is how much? Distance is under root of R square plus X square. And can you tell me what is the angle between position vector and current over here at point? Can you see the current is going into the plane? The current is perpendicular to the plane and AP is in the plane. So basically the angle between them is here will be angle between them, angle between R vector and DL vector will be 90 degree here as well as here. Is this clear, guys? Is
Yes,
it
sir.
clear why it will be 90 degree? Because the current is going perpendicular to the plane and the position vector is in the plane. So in the plane, perpendicular to the plane, can you see? The angle is 90 degree made. So if dV is the magnetic induction. Acha, please remember when I'll consider this two small elements, so I'll write it over here of length dl, है ना? So that at least the length will be defined. So if dB is the magnetic induction or magnetic field intensity at the point P due to dl, due to the current element dl,
Sir, magnetic induction at point.
point P
Okay, sir.
due to current element dl. So can I write dB is equals to mu naught by 4 pi into I dl sine. Yes, can anyone tell me what is the angle between position vector and current? 90 degree. So can I write sine
Yeah.
90 degree over here? And what is the distance from here to here? From here to here, it is how much? The distance will be under root of r square plus x square,
Under root
right?
of R square plus X square.
So this will be under root of r square plus x square to the whole square. Yes? Yes or no, guys?
Yes, sir.
Ha.
Yes,
Now,
sir.
can anyone tell me what is the direction of magnetic field? If you apply Shiv's snake rule, so then I told always remember the magnetic field will be perpendicular to this thing. Can you see this is going into the plane? So your thumb should be into the plane and you extend your finger towards point B. And when you know, when that snake will bite, will the magnetic field due to the current element at A, will it point like this? Will it point like this? This is the magnetic field due to A, yes or no? And similarly, due to B, it will point like this. Can you see both these magnetic fields are in the plane? Try to apply SSS or try to apply right hand thumb rule, whatever it's convenient for you. So this is basically your dB vector on both the sides. Okay. Hello.
Yes, sir.
Now see guys over here. If I say, let's say this angle is alpha, so this is also alpha. Yes, yes or no?
Yes, sir.
Yes, sir.
Now tell me this particular thing. If this the two are alpha, what is this and this? If this is alpha, then what is this? Can you see this line is this line is perpendicular to this line? Yes?
So will it be 90 minus alpha?
No, it won't be 90 minus alpha, it will be alpha only. See over here. Can you see this line, this red one is perpendicular to this red one? Yes or no?
Yes, sir.
So if this angle is alpha, so this line is perpendicular to this line. Can you see this particular thing? So if this angle is alpha, then this angle will be alpha. And similarly, if this angle is alpha, then this angle will be alpha. Are you getting my point now? Can you see?
Sir, could you repeat again?
I'll repeat again. Always remember this thing. If the angle between two lines is theta, then the angle between their perpendiculars is also theta. Is this a fact or not? Is this a theorem which you study in 10th grade? If the angle between
Yes,
two
sir.
lines is 90 theta, then the angle between their perpendiculars is also theta, right? So can you see this line 1 and line 2 are perpendicular to each other? 1 is perpendicular to 2 and 3 is perpendicular to 4. Yes or no? So 1 is perpendicular to 2 and 3 is perpendicular to 4. Yes or no? So if the angle between 1 and 2, sorry, if the angle between 2, oh, SN,
Yes, sir.
so I'll write it like this. So if the angle between 2 and 3 is alpha, can you see 2 and 3 is alpha? Then between 1 and 4 is also, it should be also alpha. So can you see 1 and 4 alpha? Are you getting my point, guys?
Yes, sir.
So if this angle is alpha, then this angle is alpha, and if this is alpha, this is also alpha. Yes? Yes or no?
Yes, sir.
So now at point P, the magnetic field is how much? Point P, the magnetic field is like,
So could you explain the direction of magnetic field once again?
explain the direction of magnetic field. Why these two directions? Okay, let me just. This was the current going into the plane, and 1, 2, 3, 1, 2, 3. Here the current is coming out of the plane. This is point A, this is point B. This is under root of r square plus x square. See the direction very carefully. Point A. What is the angle between current and if keep your thumb pointing towards at point A. Keep your thumb towards the screen. Did you do towards the screen? Point your thumb towards the screen at point A. Yes.
Yes.
Now extend your fingers towards point P. It should be a little bit slanted. Okay. It should be like this. Your finger should be like this. Okay. And then when you will try to draw the direction of magnetic field lines, I'll try to explain it using this thing. Now maybe it will be clear a little bit. Almost. Can you see if this was the magnetic field lined around this particular thing, then if you would have drawn a tangent at this particular point, then the tangent would have looked like this. Yes or no? Can you apply right hand thumb rule now? Yes or no? Can you see the
Yes.
direction of magnetic field is clockwise, anti-clockwise, like this, right? Yes or no?
So
Due to point A, can you see the center of this circle is at point A? The radius of
yes.
the circle is under root of r square plus x square, and when I drew that magnetic field at this particular point, so can you see that the tangent will look like this? Yes?
Okay.
Yes or no?
Yes, sir.
Similar, similar.
Uh, so I
Yes?
didn't understand how at B it's coming outside.
How at B it's coming outside? It's through this. Can you see over here? The current was going like this. The
Yes, sir.
dashed part is basically out of the plane, and the solid part is basically out of the plane, and the dashed part is into the plane, inside, behind the plane. You won't be able to see it. Okay.
Okay.
So the current was going, like from B to A, outside the plane, and from A to B, inside the plane, right? So
Okay,
when you
sir.
look it from the right, it seems like the current is going clockwise, right?
Yes, sir.
So that is why when at point B we take, the current is assumed to be coming out, and here at point A it is going into the plane. If this is the plane, then at point B it is coming out, and at point A it is going in. So that's why A and B.
Oh,
Okay.
okay, sir.
Is this clear? Yes. Right hand thumb rule clear, guys? So can you see I took A at the center of this magnetic field loop. This thing is magnetic field, right? And basically I drew a tangent over here. So I got my direction of, hello? Is this clear, guys? Is this clear ki nahi clear?
Yes, sir.
Similarly, can I do this as well? Now, can you see the center of the circle is where? Where is the center of the circle?
So will this circle be in the XY plane?
Yes, it will be in the XY plane. It is, this circle is in the XY plane. This magnetic field is in the plane. Here the magnetic field is in the plane, right? Because the current is out of the plane. So now the current is outside. So hence the direction of magnetic field will be like this. Yes or no? Apply right hand thumb rule. Can you see the current is going anti-clockwise? So basically when I draw a tangent at this point due to B, then it will be like this. Are you getting my point? How is it perpendicular? What is perpendicular to what? Now you understood?
Yes, sir.
Shall I just delete this circle now? Yes or no, guys? Did you understand this particular directions?
Yes, sir.
Please see this particular thing. If you assume this angle as alpha, then this automatically becomes alpha because it's the same thing, no? R, X, R. Is it the same thing? Yes or no? I'll just mark it with
Yes,
black
sir.
so that you will be able to understand it clearly. So this is your R, this is your X, this is your R, because this was the ring. I'm not showing the whole ring to you. Is it fine, guys? And suppose if this angle I say is alpha, and if this angle if I say is alpha, then if I try to break this dv into two different things, like this and like this. Please remember, if this is alpha, then this will be alpha. If this is alpha, then this is alpha. If this is alpha, then this is alpha. Are you getting my point? I'll relate one angle with two and three angle with four. So one and two are related, and three and four are related. Is it clear?
Yes, sir.
Angle between two lines is theta. That implies angle between their perpendiculars is also theta. This was the concept with which 1 and 2 and 3 and 4 got related with each other. Once you do that, after that, what will happen? This dv, which was out of, this thing. Can you see how it is out of the frame? So it can be resolved into two components. So here it will be dv
Theta.
cos alpha, and here it will be again dv cos alpha. So can you see the cos alpha components will get cancelled out? Yes or no? Whereas the sin alpha components will get added up. So here the small magnetic field due to the symmetric elements as only one component, that is dB sin alpha, which is providing the net electric field, net providing the net magnetic field. And it's the school derivation. You don't need to write all this. You don't need to draw this diagram again. At point P, the magnetic field is ये लिखने के बाद, guys, when you will be writing this, hello, once you have written this particular thing, just write this then. So here the small magnetic field due to the solid has only one component, that is dv sin, which is providing the net magnetic field on axis, whereas the other component, that is dB cos alpha, gets cancelled out with its symmetric element. Is it clear, guys? See, once you have written this, then you will write hence the total magnetic field is. Now the maths part will start. This was the concept part. Now the maths part will start. Okay. Have we drawn the diagram, guys? Achha, shall I write over here dB cos alpha, dB sin alpha, dB sin alpha? You tell me to move, scroll down. Guys, just tell me whenever you're done. Just tell me. The attendance is less. You tell us. Okay. So that's everyone. Acha guys, I think you have a test on when do you have test? Saturday. Current electricity. People?
Okay, sir. So this Saturday?
Yes, this Saturday. No? You already received the message in the group, right? Yes or no?
No,
So
sir.
Arey
no
kahan hai?
message was
No
posted
message
regarding
was
the
there.
test.
No message was sent.
What is the date today?
16th, sir.
Means
I saw one message of current electricity, but I don't know where. Let me ask Priyanka. Ma'am. Let me check whether the test is this week or next week. Last week only you gave the test for physics, right?
yes,
Huh?
we gave for electric capacitance and potential.
For the last week only you gave.
Last week I think was maths test.
The week before that.
Let me check. Mhm. 11, 12, 18th. When is 18th? Tomorrow, no? No,
Saturday.
that Saturday. Yes, I have already planned current electricity over here on Saturday. But I don't think so. Guys, I think It was a miscommunication with Priyanka. She's saying कि आपने reply नहीं किया तो चलो अभी I told her to message you again. मैं तो बोलूँ I saw the message somewhere, but you know it was like Priyanka ma'am sent me, and she was just waiting for my approval. She sir, I have to send this. Should I send it or not? Guys, hello, hello.
Yes, sir.
Yes, sir.
You will be having a test on this Friday, current electricity. I don't think people need much revision on that.
So
because
Friday?
No, Saturday.
Okay.
Okay, sir.
We people have already spent enough time on current electricity. Even RC circuits will be there. A little bit only, you know, those questions which are based on either steady state or, you know, that either t equals to 0. Anna? Is this clear, guys? I told her to, you know,
Yes, sir.
drop the message again. It was not dropped in the group, but it was dropped to me, and she was just waiting for my approval. So my bad. But I think you people are still prepared. Even if it's my mistake, I know. At least it will be like, you
Yes,
know,
sir.
a very short-term surprise for you people. Anyways, so did it till here, guys? Guys, will you write till here? So basically, the total magnetic field at point P will be equal basically the integration of dB. Which component? Sine alpha, cos alpha. Because
Sine
cos
alpha.
Sine
sine
alpha.
alpha, and for the whole ring you will be for the whole ring we'll do what? Integrate it.
Integrate it.
So what was dB equals to? dB was equals to, can you see?
Sine
dB was
dl
the
sine
magnitude. I gave it over here. Mu naught by 4 pi IDL sine 90. I'll write it as 1 and r square plus x square. So this will be mu naught by 4 pi IDL upon r square plus x square. Can you see the under root and square I'm not writing? Multiplied by, what is sine alpha? Do you remember this triangle over there which got formed? R x, and this was under root of r square plus x square, and this which was at alpha, right? So can anyone tell me
Yes.
what is the value of sine alpha over here? Will it be
r
r
by
upon
R by root of
root
R
r
square
square
plus
plus
X
x
square.
square.
r square plus x square? So can you see from here, this will be mu naught by 4 pi, a constant, it will come out. I is current was constant in the loop, right? So I will be constant now. The radius of the loop was constant, so even R will constant. R will be constant. It will come out, right? Yes or no? See
Yes,
this
sir.
term under root of r square into r under root of r square plus x square into under root of r square plus x square. So will it be under root of r square plus x square to the power 3 by
Raised
2?
to 3 by 2.
But will it be a
Yes, sir.
constant? Because r is a constant, and you know the distance. Since you are finding out the magnetic field at a fixed distance, so hence even x is the constant, right? For this particular.
Yeah.
So here I'll write it as r square plus x square also coming out of the bracket, and only what is remaining in the integration is dl. So when I integrate this dl, what will I get? When I integrate this dl, what will I get?
L.
What? And what is the length of the whole loop? Integrate this length of the loop. Do you remember?
2 pi r.
2 pi r. So
Yeah, 2
basically
pi R.
integrate this dl to the whole loop, I'll get 2 pi r. So this will be multiplied by 2 pi r. Okay. So basically when you solve it finally, the final answer will be mu naught by 4 pi into 2 pi I r square upon under root of r square plus x square to the power 3 by 2. Is this clear? Is this clear, guys? Can you
Yes,
see
sir.
it has a small analogous, you know, a slightly analogous with this thing. You had a ring charge, Everyone remembers the ring charge? Guys, everyone remembers the ring charge, right? Hello? This is lambda coulomb per meter, and at a point P x there is a R. We want the what is the electric field? Electric field will be equals to K lambda x upon under root of R square plus x square to the power 3 by 2, where K is nothing but what? The constant, the constant. Under root of R square plus x square to the power 3 by 2, under root of R square plus x square to the power 3 by 2. Here it is 2 pi I R square, here it is lambda multiplied by x. Yes or no? So can you see over here just the numerator is dependent on the x value, whereas here in this case the numerator is independent of x. Only the denominator is that, right? In the case of gravitation, if suppose if this ring was of mass capital M, can you see the symmetry, guys? The gravitational field due to this ring will be gmx upon under root of r square, oh, sorry, the same, r square plus x square to the power 3 by 2. So can you see everything is symmetric, very, very symmetric over there. Due to a ring it is there, then that constant was replaced by the universal gravitational constant. Oh, it was not k lambda, it was k qx. Alright. Is this clear, guys? So then can you see the charge, mass, x r square plus x square r square plus. So everything in physics is like, a little bit symmetric to each other. Electrostatic, gravitation, and this is magnetic. So can you see the symmetry? Is this clear, guys? Guys, is this clear?
It's G capital M and then after that
X,
that's
x, x.
X. Okay.
So now can you see the similarity, guys? Any doubt in this? Never ever, sir, can we cut this 2 pi with this 4 pi and write this 2? Don't do it. You can do it, but don't do it. Personal advice. Okay? Try to remember the formula like this. That's why every formula is like, a little bit on the fingertips. If you make the similarity, then, it will be in the fingertips. Okay? Is this clear, guys?
Yes, sir.
Avini. Acha. So this is the magnetic field. Always remember. Whenever you have a current carrying wire, and at a distance x there is a point P, and I want what is the magnetic field magnitude. So it will be 2 pi I r square upon r square plus x square to the power max. Is this clear, guys? The analogy, is this clear? The electrostatics, gravitation. Yes or no? Hello? Is the analogy clear, guys?
Yes, sir.
Also, note the second point. If n turns of the coil are present, that implies if you have a coil and you have multiple number of turns in that particular coil, and then the magnetic field due to one coil is basically this. Due to n coil, it will be mu naught by 4 pi, you'll just multiply it with n. So can you see 2 pi into n I r square plus x square to the power 3 by 2. So whenever it is n terms, you just multiply it with n. Is this clear? Is this clear, guys?
Yes, sir.
It's a special case. What is the magnetic field at the center of the loop? We already know the formula for magnetic field at the center. Is it equals to mu naught by 4 pi into twice of pi I by r? Yes or no?
Hmm.
So this formula we already know. Can you see in this formula, if I put x equals to 0, I'll get the center thing. Yes?
So you don't recommend like canceling out the pi and 2, right?
No, never.
Okay.
You'll never ever do this. Let mu naught be mu naught by 4 pi be mu naught by 4 pi. Because this is a simpler value, no? Which is 10 to the power minus 7 just.
Oh yeah.
So B center will be equal to, can you see if I just do this as 0, so it will be r square to the power 3 by 2. Will it be equals to, don't write this n as of now, so mu naught by 4 pi into twice of pi I into r square, and this will be r square to the power 3 by 2, it will be r cube. Can you see r square and 1 will get cancelled, only 1 r will remain. So can you see, even with the help of this formula also you are getting the same result. So that implies our approach is correct. Is this clear?
Yes, sir.
Shall I give you some questions based on this? Hmm?
Yes, sir.
Yes, tell me.
Yes, sir.
That's why I don't like this. Anyways, so now see this thing, guys. I'm drawing a small diagram. This is your x-axis. This is your z-axis, and this is your y-axis. Okay. Hello, guys. Is this clear? Negative y, negative z, and this is negative x. So basically, there is a wire which is coming from the negative x-axis from infinity. Okay, guys, can you see this wire which is coming from infinity, negative x, and it goes circular quarter circle here. Then it goes up. Then it goes the quarter circle again. Can you see this thing which is happening? Is it's in the xy plane. This part R is in the xy plane. Only this last part. Can you see this last part which I'll be able to now I'll be drawing this last part. The current direction is like this, and let's say the wire goes like. Can you see the last part of the wire, guys? This part is coming along the positive z-axis. Can you understand the question? It's a 3D wire. Can you see? This is A, this is 2A. I'm asking you, what is the net magnetic field? What is the magnetic field vector at the origin? Yes. If you remember, I told you in every question where you have multiple parts, and can you see this question can be broken into various small parts, right? Semi-infinite wire on the axis. Can you see this point O is on the axis of the semi-infinite wire? Yes. Yes or no? Can you see this point is at the center of this quarter circle? Finite wire axis. So basically this question can be broken into 5 different parts: 1, 2, 3, 4, and 5. And their direction can be calculated individually and hence added vectorically. है ना? एक बार ट्राई करो करने का, नहीं होगा तो मैं बता. Okay guys, try to do this once. If you couldn't do it, then we'll do it. And just give it to me. तब तक करो, ट्राई करो.
Sir, shouldn't there be a measurement from O to the fifth, like the line that's like joining with the negative y-axis?
Yes, done. See, I'll just do one thing. We'll mark these: 1, 2, 3, 4, and 5. Okay, let's try to talk about individual wires. Can you see the magnetic field due to first wire? Can you see first wire is a semi-infinite wire? You need to identify these cases. Hello guys, are you able to hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So it's a semi-infinite wire, and the point O is on axis of this wire. Yes or no? Yes. So can you tell me what is the magnetic field due to a semi-infinite wire on the axis? Is it 0? Yes. So
Yes,
first
sir.
V1 vector will be 0. Now second part, can you see a quarter circle? The second part is basically a quarter circle of radius A. So what is the magnitude? Can anyone tell me the magnitude? Mu naught
Mu
by
by
4 pi
4 pi. I
into
by 2 A pi.
I by R into
Pi
pi
by
by
2.
2. नहीं मैं बाद में खाऊंगा क्यों हाँ तो बनाया ना
Can be A, right? I by A.
I by A. Yes, perfect, perfect, perfect. So is this clear, guys? Can you see the radius is small a? So basically you'll write it as small a wherever there is this. Guys, is this part clear? Hello?
Yes, sir.
And can anyone tell me what is the direction? Can you see the circle is going clockwise, right? Can you see the two part is basically clockwise, right? So can you see your thumb
Yes.
is pointing towards the negative Z? Can you see your thumb is pointing towards the negative? Can you see it is pointing inside the negative Z, right?
Yes, sir.
So hence, if it is negative Z, so you'll write minus K cap. So can you see?
Sir, one
Uh-huh.
minute. I didn't understand what is this. I mean, I didn't understand the minus Z.
Can you see this Z axis is whatever is coming out of the plane was plus K cap? Can you see the direction which I
Yes,
gave was
sir.
plus
Yes,
K,
sir.
and whatever is going into the plane is minus Z. So since the magnetic field of 2 was going into the plane, that's why I wrote minus K cap over here.
Oh,
Or
okay.
is this clear?
Okay, sir.
Now,
Okay.
third part is a finite wire. Acha, what will be the length of this finite wire? Can you see? From here to here is 2A, and from here to here is A. So what will be this length? A, right? 2A minus A.
Yes, sir.
It will
Yeah,
be wire
yes,
of
sir.
length A. But point O is again
On the axis.
axis. So this is what you need to identify in every case, guys. I'll give you one more question like this. So again 0. Is it clear?
Yes, sir.
Fourth point. Now fourth part is basically what? Again a quarter circle of radius. How much?
2A.
Of radius 2A. So hence the magnetic field due to the fourth part will be mu naught by 4 pi into I by, what is the radius? 2A into pi by 2.
I
Yes
by 2.
or no?
Yes,
And
sir.
tell me what is the direction again? Can you see the current is going clockwise in XY plane? So again it will be.
Minus K.
Minus K.
Now are you getting the hang of it?
Yes, sir.
Yes.
Now fifth point is basically what? Fifth part is basically, can you see this is a semi-infinite wire, and we need to find at a distance 2A. Can you see the perpendicular distance 2A? Yes.
Yes, sir.
So it's a semi-infinite wire, and point O is at a distance. I am not writing these things from the next time, na? That you need to figure out every time. At a perpendicular distance 2A from it. So basically this magnetic field due to fifth point will be equal to mu naught by 4 pi I by R. And what is the R? What is the
2A.
distance?
2A.
Very good. So
2A.
basically I by 2A into, and into what is the direction? I think this is the formula, right? Mu naught by 4 pi into I by
Yes,
R.
sir.
If it was a infinite wire, then it would have been 2I by R. Yes.
Yes, sir.
So now tell me. Ah, there,
Yeah.
can you see your thumb is pointing towards you? And can you see if you
Yeah, so
apply
plus
it,
K.
it will be plus K, it will be going minus J.
Minus G.
Can you see? Point your thumb towards you. Can you see the current is coming on the positive Z axis and the point is situated towards the left of this wire? Hi Anna. Can everyone
Yes,
do
sir.
this?
Yes, sir.
My hair is a little bit messy, otherwise I would have on my video. Let me check. 1 second. Can you see me, guys? Can you see the current is pointing towards me?
Yes, sir.
And the current
Yes,
is
sir.
pointing towards me. The point is towards the left. So you raise your fingers and can you see? It is pointing
Yeah.
towards the negative Y.
Yeah. Okay. Yes,
So
sir.
basically, negative Y that implies minus J. So you'll write it as minus J cap. So what is the total magnetic field? The net magnetic field will be basically the sum of all vector sum, because magnetic field is a vector quantity. Is this clear, guys? So I think
Yes,
this
sir.
will be equals to tell me,
Can you explain minus J again? I don't understand.
minus K ki minus J.
J.
Okay. So see this wire, fifth wire. Just focus on this wire, this one. Okay.
Yes, sir.
So this wire is coming towards you. And can you
Yeah.
see the end of this wire? Can you see over here? This is the end of this wire from where the point
Yes,
O
sir.
is like this. So basically like this towards the
Okay.
left. You do that. When you will do it, you will understand. Don't see me. You try to do alongside as I'm doing.
No,
Right?
I'm not seeing you. Yes.
हाँ.
Okay.
And then उसके बाद just make this snake-like structure and bite it. So can you see it is biting in the negative Y?
Yeah.
So
Okay.
hence,
But why did we take it like that?
why did we take it like that? मतलब?
But the wire is like this, right?
The wire is like this, so that's why we're taking it like this. Okay.
Okay. Okay.
So what will be the final answer? The final answer will be mu naught by 4 pi into I by 2a minus j cap plus, can you see this was minus k cap and this was also minus k cap. B2 and B4 was minus k cap, right? So mu naught by 4 pi into I by a pi by 2 plus mu naught by 4 pi into I by 2a into pi by 2, and they both were minus k cap. Yes? Is this the final magnetic field? Yes or no? Can you say I can take mu naught by 4 pi common? Can you see I can take I and A also common? Yes? Mu naught by 4 pi I A, mu naught by 4 pi I A, mu naught by 4 pi I A. I can take it as common, right? Yes or no, guys? And this will be
Yes, sir.
minus 1 by 2 j cap. Can you see? Only minus is remaining and this 1 by 2 is remaining. So minus 1 by 2 j cap. And then minus, can you see here it will be pi by 2 plus pi by 4. Can you see pi by 2 plus pi by 4 is how much? 3 pi by 4. And that's the final answer. Is this clear? This is the net magnetic field across, and if someone asks you to find out the magnitude, then you know how to find out the magnitude of any vector, right? Under root of is this clear, guys? Did you understand it clearly?
Yes, sir.
I'll give you one more question just like this, or let's try to do some more questions, then you will get the hang of this as well. है ना? Next question, question number 2. Hmm. Can you see a loop, right? Everybody is able to see a loop, right?
Yes.
This loop is in the xy plane. This loop is in the xy plane, and the current flowing through it is in this direction. Yes. Can anyone tell me what will be the net magnetic field at this center? How many parts? How many parts, guys?
4.
4 parts. So basically, one is this 3/4 circle, second is this finite wire, third is this, and fourth is this. So basically, I think it is doable. Do it and tell me what is the answer. And this radius is A. From here to here, the radius is A, and from here to here, the radius is B. Small and small. If I do B2 and B4 will both be 0. Yes? Yes or no, guys?
Yes, sir.
And what will be the magnetic field due to 1 and 3? The magnetic field due to 1 will be equals to mu naught by 4 pi into I by A into 3 pi by 2. Yes? Can you see the angle is 3 pi by 2 now? 90, 90, 90. So 3 pi by 2. And what is the direction? So can you see the direction is, yes, so into the plane. Are you getting my point, guys? Similarly, what is the magnetic field due to 2? Magnetic field due to 2 will be mu naught by 4 pi into I by the radius is B, and this is only pi by 2. What will be the this thing? Again into the plane. Yes or no? So can you see what is the total answer? Final answer? Guys, everyone understood?
Yeah. Yes.
Can I
So
put it?
B3, yeah.
B3. Yes, it is B3. So B net will be equals to mu naught by 4 pi. Common hai. I is common, even pi is common, and even 2 is common. Okay. Here it will be 3 by plus 1 by, and the direction is into the plane. Is this clear? Shall I give you one more question like this?
Yeah.
So basically, after this, I'll just need to be, doing only 2 things: the toroid and the solenoid and the toroid. Only these 2 things will be done, and this part of my MEC will be over. Then we'll start with Ampere's circuital law. And once that is also over, the whole, this MEC unit is finished. MEC is smaller as compared to electrostatics. Okay. So don't think like I said, it's a very big. After this, we'll start with EMI, and after EMI, we'll start with magnetism and matter. Sure. Question. There is this circle. There is no wire over here, right? But this is, I'm telling you, this is just a part of a circle of radius. How much? This is the center R. Now, I have a wire only at this much part. Can you see a loop over here, guys? This is a typical question. थोड़ा सा दिमाग लगाना इसमें. Only 2 parts are there, but those 2 parts are typical. the current is going like this and like this. Can you see the wire is only in the shape of this D? Can you see this D there? Right?
Yeah.
This
Yes.
D is basically subtending at angle of 120 degree. 120 degrees how much? Guys, can anyone tell me 120 degree in radians is how much?
2 pi by 3.
2
Yeah.
pi by 3. 360 divided by 3 is basically 123. Na? So now the question is, find the magnetic field at point O. Try to do this two parts. Important. Can you see this is a finite wire? Everyone can see this is a finite wire, right?
Yes,
The
sir.
distance of this wire from point O is something. You need to calculate that something. Okay. थोड़ा सा typical question है. It's a little bit good question. करो. I'll write it for you. This, let's take this as your part 1 and this as your part 2. So B1 will be equals to circular arc subtending 2 pi by 3 radians at center. So basically this is easy. Mu naught by 4 pi I by R into twice of pi by. Is this clear? Is this clear, guys?
Yes, sir.
And what will be the
Yes.
direction? It is coming towards me, right?
So
Yes or no?
Yes, sir.
One. Now what is the second part? Can you see second part is basically a finite wire which is subtending how much angle, by the way? Can you see this finite angle? This finite wire is basically subtending an angle of 120 degrees. So if I say this is the median, then will this be 60 and will
60.
this be 60? So here in this case, alpha and beta are both equals to 60 degrees. You just need to find out this distance from O to the wire. So basically that will be acting as your R, right? So you need to find out that R. We know the formula for this thing, no? B2 will be equals to mu naught by 4 pi I by R into sine alpha plus.
and alpha sin beta.
Yeah,
Sine
we
beta.
know this formula already. So we just need to find out this R. How will we do it? Can you see this triangle? The upper one. This is 60 degree, this is R and this is small r. So what is the relation between them?
Cos 60.
So R by capital R is basically cos 60. And what is cos 60?
1 by 2.
So basically small r is capital R by. So here in this case B2 will be equals to mu naught by 4 pi into I by capital R by 2 into sine 60 plus sine 60. And what is the direction of this? What was the direction of current? Was it going up to down or down to up? Up
Down to
to
up.
up. So basically this will be the direction. So hence what will be the direction? Into the plane, right? This is into the plane. Everyone, is it clear? So now can you see, guys, the first one is out of the plane, the second one is into the plane. So this will be equals to mu naught by 4 pi. This 2 I'll shift it above, right? Shift it to with this. So I by R and into the brackets to twice of sine 60 is root 3 by 2. So 2 set 2. Oh, no. This is twice of root 3 by 2 and this is your 2y. Is this clear? So this 2 go ups goes up. Sine 60 plus sine 60 is twice of sine 60. So this and this will get cancelled. This will be mu naught by 4 pi into I by r into how much? 2 root 3, right? Yes or no?
Yes, sir.
Into the plane. And this is how much? Mu naught by 4 pi into 2 by pi 3. Now tell me, since both of them are acting in the opposite direction, the one which is bigger only that will be prevailing, right?
Yeah.
So which is bigger?
Yes, sir.
Is 2 pi by 3 bigger or 2 root 3 bigger? See, pi by 3 will be approximately 1 by 1 point something, right? Because pi is 3.14, so 3.14 upon 3 is, this will be nearly 2, right?
Yeah.
Yes or no? And what
Yes.
is this 2 root 3? Root 3 is 1.732. So 1.732 multiplied by 2 is obviously greater than 2, right?
Yeah.
Yeah.
So basically the net magnetic field will be B2 minus B1. Although I am doing this only. I am doing this only B1 vector plus B2 vector. But can you see the bigger minus smaller? So this will be ultimately what? Mu naught by 4 pi I by R 2 root 3 minus 2 pi by 3, and the net direction will be this, the direction of the bigger magnetic field. Is this clear, guys?
Yes,
So
sir.
this question was a little bit typical question of JEE Advanced. So ऐसे questions आ सकते हैं. All the other questions are like JEE Mains or NEET basically. I'll give you one more question. Mhm. And some homework question also I'll give you, no? So don't think I will not give any homework questions. Homework questions will also be there. There are two wires. One wire is over here, one wire is over here. They are situated at the corners of a, they are situated at the ends of a equilateral triangle of side A. Now the question is if on this the current is coming out at point A, the current is coming out, at point B the same current is going in. There are two current carrying wires. Can you see two infinitely long current carrying wires in opposite direction are at the two vertices of an equilateral triangle. Find the magnetic field due to them on the third vertex. हो जाएगा? Will we be able to do this question, guys? Karo?
This
Do
is
it.
the homework, right?
No. You need to do it now. Homework question I'll give you after some time. मतलब cut देने वाला हूँ. What is the time today? 14:57. Until when is the class?
3:30.
हाँ. फिर no problem. I'll give you the homework question and most probably we'll do the solenoid and toroid as well. At least solenoid will be able to do. And one result I'll give you. For finite solenoid, large current carrying sheet is not necessary. The derivation to prove it. And then Ampere circuit law. Toroid is in that. Okay. So आज we'll be finishing the at least that much part, so that in the next class we'll be starting with Ampere circuit law. Anji, so can you see the current at point A is coming towards you, right? Current at point A is coming towards you, and you'll just open your finger towards point C, right? Open up your finger towards point C. So current is coming towards you. Are you able to see me, right?
Yes, sir.
Yes,
Please,
sir.
please turn the video on so that you can see me at least. Okay, guys. So if I have current which is coming towards me, I'll open my finger towards C. So can you see my fingertips open towards C? So when I, bite the snake over there. So will the magnetic field due to current at A, will it point like this? Yes? Will it point like this, guys?
Yes, sir.
So this is the magnetic field due to A. Similarly, acha, this angle will be 90 degree, right? If I choose like this, can you tell me if this is 60 degree, then this will be 60 degree, right? Alternate interior, this is 60 degree, then this will also be 60 degree, and this will be 30 degree, right? Yes or no, guys?
Yes, sir.
Okay. Now
Yes, sir.
similarly, we'll look at point B. So can you see point B, the current is going into the plane, and I'll move my fingers like this. So can you see now from B to C? Yes or no? And then I'll bite at that point. So please remember the magnetic field due to this will be like this. This is the magnetic field due to the point B. And can you see this is 60 degree, again this will be 60 degree, and this will be 30 degree. So now can you see over here that you got two different magnetic field due to A and B, both at 30 degree with the horizontal, right? Yes or no, guys? This is important. See, I told you na hamesha कि whenever you deal with a vector quantity, think of the direction and then write the magnitude, right? Yes or no? So we
Yes.
are thinking of the direction by giving these angles and all, by using right hand thumb rule and all. So once you're done with the direction, then you just need to write the magnitude. What is the magnitude? What is the magnetic field due to A? The magnetic field due to A will be equals to, can you see it's an infinitely long wire, so mu naught by 4 pi into twice of I by, what is the distance from here to here? A, right?
A, yeah.
So this is the magnitude, and the direction we know. Even the B1 will also be having the same magnitude, right? Yes?
Yeah, yeah.
Yes,
So
sir.
now, if you remember the concept from grade 11th vectors, two equal vectors, can you see two magnitude is equal, right? If this angle is 30, this angle is 30, what is the angle between them?
120.
So two equal vectors at an angle 120 degree. Will this be the resultant of these two vectors?
Yes.
ये याद है सबको? In
Yeah.
grade 11th we did already, these things. Those who came new, we took on extra lectures on vector, right? Guys, did we do one extra lecture on vectors? Hello? Hello?
We did an integration differentiation.
We did integration, differentiation. Did we do vectors?
I think I'm not sure.
Even I think so. So anyways, if you don't know that formula, it's okay. Can you see over here? A square plus B square plus twice of AB cos phi, right?
Hmm.
So twice of B square into cos 120 degree. What is cos 120, anyone?
-1/2.
Minus 1 by 2. So this will be B square plus twice of B square into minus of 1 by 2. 2 se 2 katega. This minus B square will be there. 1 minus B square and 1 plus B square will be cancelled, and the final answer will be B. So can you see the net magnetic field is equal to the, at least always remember, it is always on the angular bisector. When the two vectors are equal, then the resultant is always on the angular bisector. And this angle should also be 60 degree, and this angle should also be 60 degree. angular by theta. And what is the magnitude? It is equal to that of the vector. So the final answer is twice of theta. Check.
Understood, sir.
Chaliye. Now I'll draw some homework questions for you people. Everyone, are you comfortable enough in electricity? Current electricity, everyone is comfortable, right?
Yes, sir.
If you are comfortable in current electricity, then the next chapter is going to be very easy for you. Electromagnet, matlab, a little bit understanding part is still there, but it is going to be easier, right? Similarly, if your electrostatics is good, then this third chapter should be good. Are you getting my point? Although we are not defining like magnetic potential and all. We are not talking about all that. We are just talking about the magnetic field. So this chapter, that's why it becomes very small. We talk about electrostatic potential and all in electrostatics, but here we don't talk about magnetic potential and all. Okay? Chale. So next question.
So at point C, we have to say in what direction that
It
magnetic
is
field acts. So what are we saying?
perpendicular to the line joining A and B.
Okay, sir.
So it is always perpendicular to the line. Not always. In this case, it is perpendicular to the line joining A and B. Away from it. So anyways, next question. Homework questions now, Anna. So there is one question like this. Can you see a current carrying wire? Guys, can you see a current carrying wire? It is going till infinite. Do you remember this type of question we already did in electrostatics?
Yes.
You can take a reference. It
Yes,
has to
sir.
be done using subtractive method. Okay. So I'll give hint. Subtractive method. I already told you about subtractive method in the last. Acha, guys, do you think whatever we are doing over here, what concepts of physics are we using over here? Here we used additive method. Yes.
Yes.
That's why
Yes, sir.
we are using additive method. And what is this? This is principle of superposition. Can you see? The net will be the vector sum of all.
Yeah.
So
Yes,
basically
sir.
we are using two different things, principle of superposition as well as additive method over here. Similarly, principle of superposition, additive method, principle of superposition, additive method, principle of superposition, subtractive method. Okay. Okay. अरे हाँ या
Yes,
ना
sir.
यार बोलते
Yes,
भी
sir.
नहीं हो यार बिल्कुल भी तुम लोग चुपचाप. So next question. So what do you need to find out? You need to find out the magnetic field at point P, which is at a distance of r, 30-degree angle. Current is I. Okay. Is this clear?
Yeah.
Yes, sir.
Next question.
So this is a semi-infinite wire, right?
Yes, it is a semi-infinite wire. Can you see? Only not also a semi-infinite wire. The point P is not at one end. If the point P would have become like then it would have been a direct case semi-infinite wire at its end, right? But can you see that point P is at a 30-degree angle lesser, deeper than this thing. This end is at an angle of 30 degree from point P. So that's why basically what will you do? You assume like this semi-infinite wire minus a finite wire of 30 degree. Is this clear? So that's why subtractive method. Will you be able to do it now? Okay, na? I'm not doing it. May I assume kar raha hu ki you people will be able to do it. Guys, don't draw it, na? Or otherwise you can draw exactly like I'm drawing, because the question will feel like it is a little bit interesting. I can never draw this, so that's why I need to draw it like this. Guys, can you understand the question now? Can you see it's basically a part of two different circles?
Yeah.
So the current is going like this. Current is flowing clockwise in the loop. It basically, now you know the concepts, right? You know all these things will be passing through the center. You know this thing. मैं क्यों बता रहा हूँ? Why am I telling you? No. So try to find out the current due to this figure at point O, and the radius is A and B. Where is the marker? No. This is A and this is B. A is equals to 0.08 meters. B is equals to 0.12 meters. The current is 10 amperes, and the current of 10 ampere blows around a closed path in a circuit which is shown in the horizon. The circuit consists of 8 circular arcs. No, number of turns is not given. So this is it. Is it okay, guys? Will you be able to do it?
Yes, sir. So can we discuss the answers too, like the next quizzes?
The final answers to this is 6.54 into 10 to the power minus 5 Tesla. The answer for...
Sir, isn't this the same way we did the first question, which is substitute the
Yeah.
values, right?
Yeah. Yes. But it is, please not, please remember, can you see it is 1 by 4, 1 by 4. Can you see 1 by 4, 1 by 4, 1 by 4, 1 by 4? No, sorry, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Can you see this is 1/8 of a circle, right?
Yes, sir.
So 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. ऐसा करके there are 8 portions, different areas. So accordingly, the answer for the previous one should be... No, the previous one I don't have any answer with me. नहीं, I don't have it. तो वो मैं बताऊंगा भी नहीं, इसमें आंसर आना जरूरी नहीं है. This is also a homework question.
So will the answer be mu naught by 4 by 1 by 2 r?
Something like this, because this will be, you know, अरे यार मैं अभी नहीं करना चाह रहा हूँ. We will do it in the next class. You people are very clever and now understood this particular thing.
No, sir.
So next question. This question is a bit good. To understand it will take a little bit time. Suppose So guys, can you see one x-axis, y-axis, and a z-axis? So these are your positive x, y, and z. Okay, guys, is this clear? Hello.
Yes, sir.
Now
Yes,
the
sir.
wire is basically coming from here. Okay, this is at a distance of a units. Then it goes up. Then it makes a right angle triangle. This distance is also a up. Okay. This angle is 45 degree. Then it comes like this. Everything now has been happening in xy plane. Till now everything is happening in xy plane. Now this is from xz. It goes like this. Can you see over here? This is an xz plane. And it's a quarter circle again of a radius a. Is this clear? And after this, it goes into the negative y-axis again. Till infinity. This is the direction of current. You need to find out what is the magnetic field at point. Again, this will be done how? Again, using additive method.
Additive method.
Additive method.
Only
Principle
this
is
thing is a little bit typical. Only this part might give a problem to you people. Otherwise, this question is also easy. So try to do this. I'll write down the final answer. Mu naught by 4 pi into I by A. This is the final answer, okay? Into I cap minus pi by 2 j cap minus 2k cap. Okay?
Yes, sir.
Okay. So this is one more homework question. One more. And last, I guess. This is done.
So could you scroll up?
Yes, please draw it. Please draw it.
Thank you, sir.
Sir, I have a doubt on the previous question.
Which one? This one?
Sir, this one, yeah.
Hmm.
In this one, both will be 1 by 8. Even the, what do you call, that will be 1 by 8. And then there's one more semicircle, quarter kind of thing, right?
This is 1/8.
Also,
Quarter is
yeah.
this. It is half of the quarter.
Okay, and
This is half of the quarter. Are you getting my point?
what will be the other small thing?
That will be also a quarter. That will be also 1/8. Can you
1/8
see
will be,
this whole
okay.
circle has been into 8 pieces? 1, 2, 3, 4, 5, 6, 7, 8. Out of these 8, 4 are not present, 4 are present. Similarly, out of these 8 pieces, 4 are present, 4 are not present. So basically, this is 1/8 of a circle. 1/8 is basically how much? Pi by 4. Pi by 4 is 45 degree. Yes.
Yes, sir.
So this is 45 degree. No? So pi by 4.
Okay. Okay, sir.
Please draw the figure very carefully. Hello. Hello, guys. Hello.
Yes, sir.
Yes, sir.
So I'm giving you one more question. There is an infinitely long wire present carrying a current I, and there is a square. Can you see this square is very close to this one? Guys, can you see this square is very close? Basically, this distance is negligible between the loop and the square is negligible, although they are not touching each other. Or even if they're touching, the wires are insulated. Okay, so current will not be traveling from one wire to other. So in the square loop, the current is going. The current is going anti-clockwise, no, clockwise, and this wire, the current is going straight like this. You need to find out what is the magnetic field at the center of the loop. Find magnetic field at the center of square loop and compare this this is again the same square, guys. It's a square. Length of the square is 2a. Let me take it 2a. No, let it be a only. Yes, guys. So basically, these are your questions for homework. You basically need to find the magnetic field at the center of the square loop in both the cases. So can you see here in this case, and the current in both of them is equal, II, and tell me this thing and this thing whether they are equal or not. Okay,
Yes,
guys.
sir.
From here you will learn something. Okay, so do both the parts individually. So practice भी हो जाएगी magnetic field निकालने के, and then you will learn something. What will happen to current of these two things? Okay. Chali. That's it for today. In the next class, we'll be doing the solenoid thing, and we'll talk about Ampere's circuital law as well, and we'll do the Ampere circuital law as well. When is the next class?
Saturday.
Acha, by the way, due to the change of schedule, my 2 classes have been lost on Monday and Tuesday. In the previous schedule, my classes were on Wednesday, Thursday, and so on, right?
Yes, sir.
But since the schedule changed, then I lost 2 classes. What to do now? Chalo जाने दो. We'll cover it someday, some other day in summer vacation. Most probably 30, 31st. We'll try to do. Okay.
Okay, sir.
Sure.
Okay, sir.
Okay, guys. So, okay, we'll see you again in the next class, guys. Thank you.
Sir, if we have a doubt in any of the homework questions, you'll discuss it, right? Tomorrow
Obviously.
or your next class.
Don't I discuss it in the next class?
Yeah.
You people don't ask me. That's why I don't discuss. I thought think हो गया आपको question तो. You people say कि sir, I didn't get this question, so we'll solve it. I think we already did some questions like this. Sir, I couldn't do this question, so we solved it over there. So anyways, Chalo.
Okay, sir.
Thank you very much, guys. We'll see you
Thank you,
again in the
sir.
next class.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.